Making Aero is a lot like making particles. That's the beautiful thing about Bifrost, is that the simulation system is all very standardized. And this is really helpful. So if I want to make some Aero, okay. Basic aerograph. Same as before, right click on that one and explode it. So once again, you have source, collision, solver settings, and simulate, just like particles. Exactly the same sort of thing. Makes things easy to remember once you get used to it. So we're going to need to get some geometry in here. Luckily, so this is our little burner. I just pasted it in. I'll make sure that it's supplied for you. Let's just quickly ungroup that. Do some Maya tutorials while we're here. Go to edit, go to ungroup, and we'll just rename this so it doesn't have pasted in it. There's our burner. So what we're going to do is make some smoke come on out of this cauldron. Yeah, let's get on to doing that. So it's like we were doing with particles. Like I was saying, we have source, collider, solver settings, Aero. We've also got influences coming up, which is fine. So what we're trying to do is just make some steam or smoke come out of this burner. I'm going to call it a cauldron, or marmite. So let's drop that in here first. This is going to be our collider. And that's all we're going to use it for at this point. So we'll pop it in there. And that's cool. What I want to do though is I'm going to need something to emit my steam and smoke from. So let's drop in a sphere like that, and we'll just drop that in there. And let's put it in a terminal so we can see what's going on. Pop that in there too. So there's our sphere. It's almost in the right position. It probably is in the right position. It's just a little big. So let's just scale that down. Something like a bit less than that, maybe 0.5. And this is going to generate some smoke for us. Of course, what we want to do too is have a look at what's coming out. We need to see the Aero volume coming out. So let's throw down an output, and we can just plug this straight in, go back to the beginning and press play. And you can see we've got some very basic mushroomy looking smoke coming through. That's a good start. But if we really want to get it to look a bit more like steam, especially in the viewport, we're going to need a shader. So let's assign a shader. So assign material. And all I'm going to do here is right click on the volume material, create node, Arnold standard volume map. Okay, so this is basically going to help us visualize in the viewport what things look like. And we can go into here, we can change the density of it. You can see it, that's reflected. What we really want to change here is, I believe, the scattering. What I want to do is I want to push that color up over white. Let's set this to 5. There we go. So now we've got a bit more of a steamy thing. That's not really the best way to do it, but this is like the first 5 minutes of the tutorial. You'll have to bear with me. It doesn't look much like steam or smoke right now, does it? It's kind of just like this big lump of volume that's doing lumpy volume things. Nice mushroom cloud. So obviously, just like the particles, we're going to have to jump into the settings and take a look at how things are going. So into the source we go. Enable air source, perfect. We want that. Start frame, perfect. Not using an end frame, also perfect. So we're going to change our resolution mode straight away to absolute. And this is just like volumes, where relative is relative to the size of the object, whereas absolute is based on world units. We need to see our geo volume mode. We need to change. Solid or shell means, is it a solid object it's emitting from, or so is it a watertight object? Is it a sphere? Is it a torus? That kind of thing. Or is it just a plane with no back? And you can see here, if I change this over to shell and press play, you get a slight difference there. Go back over to solid, press play again. Now we're using a sphere, so I'm just going to leave that on solid right now. And then the detail size here is just like a volume. It's how much resolution you've got. Now this is all in geometry volume conversion, which if we go and look in the info tab, defines how an input mesh is voxelized. So what it's doing is it's taking this mesh that we're putting in and turning it into a volume for us. All of what I'm going to talk us through and try and get a good look with is in here as well. So don't forget to check that. Geo detail size, just like volumes, how much resolution your fluid has. Now, You've got to talk about use fluid detail size because that's important. If I switch that on, this guy doesn't matter, and it's all driven by the fluid detail size, which is quite literally the size of the smallest resolvable detail in the smoke. So they're both set to 0.05 right now, but if I say change this to 0.2 and run the simulation again, you can see the smoke is a lot more low resolution. We'll take that down to 0.025. Run the simulation again, it'll be a little bit slower, but much higher resolution. And that, because I've got use fluid detail size switched on, that's applying to both the conversion of the input and the smoke itself. Then we've got rate. So that adds and blends a source at a time-dependent rate. You can use set, which is the fog. This is the fog density mode. And all of these, like temperature and speed, they'll have this pull down. So you can set it. You can say, I only ever want it to emit density at 2.5. This is what you're going to get. See, everything's a lot slower, and the fluid is uniform density. You can add, subtract, over, min, max, and multiply, which gives you different results. We're going to stick with rate for now. And it's time to talk about something we didn't do in particles quite deliberately because we've left it for here. It's time to talk about varying our input geometry and varying the properties on our input, or our properties on our source. We're going to use vary source property for that. So if I just plug my mesh coming in into the source property, plug that back into source here, just replace what was going on. What this allows me to do is I can change this property, fog density. I can say multiply it by 1 or 2 or 0 or whatever. I can replace the existing fog density, multiply it or add to it, and then I can set a random variation here. So if I want to say minimum 0.2, maximum of 1, bias of 0 is fine, and leave it animated. Now if I just stop that there, and let's just change our background, you can see that it's varying the fog density randomly, and it's animated as well. I can change the seed, get a different result. You can get all kinds of variations that way. Just cool. So moving along from there, we're going to have a look at some of the solver settings. A lot of these are to do with, well, the globals here especially are to do with temperature. So you've got, which don't need to worry too much about temperature just yet. That's coming with combustion, so stay with me. You've got the ambient temperature, how much temperature diffuses out, and the style. I'm going to change that to fluffy and play that again, see what we get. You're just going to get a different style of fluid, so it's going to be a lot fluffier as these things go. You're starting to really get a feeling of smoke now. You've got these fluffy, kind of smoky looking outcomes, and that was just changing this guy to fluffy. Something else you can do that isn't covered in the PowerPoint so far is when you do something to your source geometry, it's going to reflect in your smoke. So I'm just going to really quickly set something up here where I'm going to displace these points. And I'm going to displace them with our friend diffractive noise field. Tend to use that a lot. Pop that in there, and let's just get that out so we can see what it's looking like. So that's probably a little bit too much displacement right now, so I'll change the scale of my displacement. And of course what I will do too is I will put in more resolution into the sphere. Something like that. Magnitude's fine, displace points are down to 0.3. We just want to try and make sure we keep this within the burner. And we'll put down a time node. And now what I'm going to do is vary this displacement over time by taking the frame, turning it into a scalar field, and plugging that into the fractal noise. And so if we just look at this now, you can see it's changing quite rapidly in there. Still pretty much staying within the bounds of the burner. And this is going to, actually what I I might just slow that down a bit. So all I have to do is multiply the frame number by, 0.2 is fairly good for that. And then if we come back out here and turn that off, going to raise the frequency a bit so we've got more spikies and things like that. We can have a quick look now. You can start to see it's just a little more ragged coming out now. It's all being collided with the burner, but you're getting more of a smoky look to it. Even so. So that's cool. That's just a little tip. Something I do a lot when I'm making fluids is vary my source geometry quite seriously, just to get a little bit more randomness into it. So what we're going to do now is start working with influences again. Did a bit of this in particles, but what I'd like to do now is actually add some turbulence to the smoke, just like we do in the PowerPoint. And that's also why I brought this up, because now I have a system for animating any fields that I want to put in, and what I happen to want to put in right now is a fractal turbulence field. So we'll just pop this here, and all I have to do now is I can take this whole system without the factor, paste that down, pop that into the time, and then I just need another. I can change this multiply here to something like, let's go with what the PowerPoint's got, something like 0.8. And this is just animating this turbulence field. And then we can put that into a turbulence influence. And that goes into the turbulence itself. And then we can plug the influence into our influences and see how that looks. So we'll just let that get started. I might speed this up a little bit. You can see here how the field is providing turbulence to the fluid as it's rising. It's not rising straight and even like it did anymore. It's starting to break up and become more turbulent as it hits the turbulence influence in the turbulence field. So from this point on, we're really talking about the power of influences. And they are very powerful. They let you do an awful lot of things. The basics of it is this, is you emit from something. Maybe it would help if we plugged in the displace points there, a little bit more turbulence coming out. Yeah. So we're getting a really nice turbulent flow now. Everything's breaking up nicely, it's coming out randomly. This is reasonably slow to calculate, as you can see, and why I'm speeding up the video now and again. If you want to look at it faster, like I was saying, to get your low resolution look before you start refining, then it's just a matter of coming into your sources here and changing this number upwards. 0.1. It's going to simulate a lot faster, but it's going to be a lot lower in detail. Because we're really just, you see we're losing a lot of detail there. Because we're really just emitting from a distorted sphere, I'm going to turn off the fluid detail size and make this much lower resolution here. And let's see how much of a difference that makes. A little faster. But we're still getting a nice level of detail, a nice turbulence along the sides and things like that. And our fog density differences and stuff. So that's working pretty well. Just adjusting the shader a bit so we can get a much better look at our fog densities and things. So I'm just going to make some adjustments, which is, as you do, I'm going to raise the frequency on our turbulence influence a little bit. And I might also drop our drag a smidge as well. So that's got that looking pretty well. We're going to need we're going to add another influence now, which is going to be a dissipation influence. And what dissipation does is it causes the fluid to fade out, to dissipate, to spread out more and become thinner and thinner. it helps with smoke. So put down dissipation influence, and with settings we've got 0.3, voxel fog density, and background value of 0. This we just plug straight into the influences as well, and play. And you can see that the volume's a lot thinner now, and it's fading out at the edges. It's dissipating, which is exactly what we wanted. So that's cool. It's another influence to play with. What if we wanted this steam, this smoke, to be happening in the world? And, you know, there might be things going on like wind in the world. So let's add a wind influence to this and get it to blow. Like, basically we'll vary the wind direction and see what we can get. Basically, there's an influence for that. And it's just called a wind influence. And at its most basic, I'll show you. I just add a wind influence here and pop that into my influences. At its most basic, it's just going to blow our volume in a direction. In this case, it's going to be positive X, but we'll change that to, say, negative Z, so we can see it. Have a better look at it here. We'll just get this. So it's somewhere like that, probably. It's going to blow it by 5 units. Basically blow it by the wind speed. And it's going to introduce some drag, so it just doesn't all blow the whole thing at the same rate. So let's take a look at that one. You can see straight away that it's just picking up and blowing it 5 units along the negative Z. And we can, of course, vary that. So, well, we can change the whole wind speed to 1, so it's not going to blow it as hard. But really what we want to do is vary it across the volume. To vary it across the volume, to get a good look, we're going to need to use some fields. So I'm going to start with, well, first off, let's have a look at what our wind influence gives us. We've got wind speed, wind direction, and drag. So I'm going to need, by the look of it, one for the wind speed and one for the wind direction. The wind speed is a float value, which means it's scalar. So fractal noise field, which is great. We're going to animate that. So we're just going to use our time. I don't know. This one's slower than this one. Let's start with the fast one, see what it looks like. We'll plug that in there. Just to make sure I've got sort of a base level, I'm going to add a scalar field to that. So I'm going to add a scalar field of 2. And what this is going to do is, because the fractal noise field comes out negative to positive, so it comes out with a magnitude of 1, it comes out about -1 to 1. Adding 2 to it is going to make them all positive. You could do the same kind of thing here with an absolute value, like this, so that we don't have any negatives. And this, using the absolute value, gives us the advantage that we can change our magnitude and not have to keep increasing that scalar field to keep it positive. So we'll pop that into our wind speed, and then we're going to need something to vary the wind direction over time as well. And that one's a little more complicated, but it does start with a fractal turbulence field. And we'll use the same time. Let's plug that in there. And this one, it's not so much about how big the number is, it's about what direction it's going in. And we always, what we've got at the moment is 0, 0, -1. We're always going to want to do that. So let's start a vector field here. And vector field just lets you add a vector that's going to be across the entire field, and it's going to be our wind field. So I could literally plug this in here and it would do exactly the same thing. The direction would be 0, 0, -1 everywhere in the world. But what I'm going to do is I'm just going to add this turbulence field to it. So if we pop that in there, so that gives us a baseline of 0, 0, -1. And then we're adding whatever is coming out of this turbulence field, which looks a lot like the noise field in that with its when its magnitude is 1, it's roughly -1 to 1. And yeah. So at this point, we'll plug this in. And then I'm going to press play and we'll take a look in about 2 minutes. So that doesn't seem to be doing very much. There seems to be a slight lean. So let's start putting up magnitudes and see what happens. So you can see now that it's drifting, but the area of effect of the wind field is different across space, which is what fields will do. It'll give you a different value across space. So, you know, one way to get this looking a bit better is maybe for the wind direction. The speed is good. Just stop that. For the wind direction, what I'm going to do is just lower this frequency, and then we'll take another look. I think I'll push the wind speed up as well. That was probably a bit far. Let's try 6. And you get used to this changing of values and looking again and changing of values, looking again as you're building anything to do with simulation, really. Because you make, and as you do more of it, you get more and more used to it, but you still need feedback, and that's what you're doing, is you're giving yourself feedback by just changing something, doing it again. My big advice for working on anything simulated is change one thing at a time until you really, really know the system really well. Just change one thing at a time, see how it looks. If it doesn't work, change it back, change another thing. That's basically what I'm doing here, and now I'm starting to get something I'm really quite happy with. I've got a lot of turbulent smoke. I mean, I've obviously overcooked my turbulence because we're getting lots of sort of waves of smoke here, and the dissipation's a bit high, but I'm working on the wind speed at the moment, so I'm only changing the wind speed. And if I get that wrong, like you saw me just do it, when I had that up to 20, I can stop it, reset the simulation, change that one thing that I'm changing, and then run it again. It saves you time, and it sounds stupid, but it stops you from getting confused, because if I went and changed the wind speed, the wind direction, the turbulence field, the way that it was generated, what its voxel fog density was, and I got something I didn't like, then I would have absolutely no idea which one of those settings made the thing I didn't like, right? So that's just something you need to bear in mind when you're working with anything simulated. So that's particles, smoke, fire, NPM, which we're going to get to shortly, explosions, which is what we're doing next week, things like that. So now I'm quite happy with this smoke. This is a fairly good looking smoke. It's dissipating nicely. It's turbulent. It's maybe a little bit regular, and we can use some other influences to try and change that if we want to. But for today's lesson, this is pretty good. This is a pretty good looking, just a little bit of smoke coming out of the cauldron. Of course, if you wanted it to be more like steam, you could do things like, first thing you would do is just change the shader, so maybe make it a little bit more transparent, like that, but also quite a lot brighter, kind of thing. And you'd also want it to be a little more wispy, and so you can play with the settings in here. So if we go to the solver settings over here, change it to wispy, and let's see what that does, see what sort of a look we get out of that. And again, I'm just changing one thing at a time. Once I'm happy with something, I've left it alone, and I'm moving on to the next thing. So right now, what I'm thinking is that my turbulence is maybe a bit too high. So I'm happy with the wispy look. It's looking a lot wispier in there. Reset it, come back to my turbulence. So I've got two here. I've got turbulence influence, with where I could change the rate of change, and the fractal turbulence field where I could change the magnitude. So I'm just going to change the magnitude to start with, reset the simulation, and press play again and see what sort of a difference that makes. And I'll have to wait till it gets to 20 or 30 frames before I'm really going to have a notice of anything. But it's worth taking the time to get the simulation right. Because if you have to make it again and again and again and again, you're just going to lose an awful lot of time. So now we're not getting all of those big curly breakups. We're getting a little bit of turbulence, which is quite nice. I quite like it. But we're not getting the big, we're starting to maybe get a little bit there, a little bit there. But this is much more along the lines of what I'm trying to get to here. So I'm pretty happy with that. And that means I can move on to my turbulence field and bring my rate of change down to maybe half of what it was. And we'll maybe have a little less drag as well. I changed two things, but I changed them on the same compound. So I know, oops. So I know that I'm working on the turbulence influence. And again, press play, wait for a bit. Wait for it to play, 50 or 60 frames until you get to the point that you're trying to get it to look right in. Because we'll be caching this. And if we were taking this out into a game engine or out for rendering, we could cache it and say, well, there's always this big blob that happens as soon as you start. We can just cut that off as soon as it dissipates. We can simulate 300, 400, 500 frames and we can pick the bits that we like out of the cache. So this is looking a bit better. I'm pretty happy with that. Getting nice wispy uptakes, the buoyancy's good, it's slowing down and dissipating. And again, maybe I'd like it to dissipate a little faster. So I can come to my dissipation influence, which is around here somewhere. There it is. And I can just push the rate up like this. Play again. This would be awfully painful for you guys if I wasn't speeding up these simulations. So now you can see that my fluid is dissipating faster and it's giving me the look I want. So at this point, I would call myself happy and go and show my supervisor, who will then change everything, possibly on a whim. But that is the basics of Aero. Well, it's the basics of smoke. But Aero isn't just used for smoke. But before we go any further, what I'm going to do is I'm going to cache it, because basically I'm done, I'm happy. I'd like 300 frames of it, please. And we're going to cache it using the file cache, like we did with the particles, just the same. But instead of writing to a Bob file now, what I'm going to do is, let's just go to cache directory. So let's just go to my cache directory, and I'm not going to use a Bob this time. I'm going to cache to OpenVDB. So we change this to OpenVDB, and I'm going to call this cauldron.openVDB. Again, dot 1234 hashes dot VDB. Okay, so this is going to write out all of these, and this is probably more important with, this is way more important with volumes than it is with particles, is we really need to choose what properties we want to get out, because if I dump all of these out, which I can, no problem, it means that my caches are going to be slower to write and much, much bigger on disk. Really, all I want from here is I want my voxel fog density. I want the fog density and I want the voxel velocity, and that's all I want. Velocity so that I can motion blur it if I want to. Fog density because that's what it's displaying. That's what's making the smoke. So we just plug, let's just make sure our cache is in pass-through mode before we do anything with it. We'll plug this guy into here. Get rid of the watch point, and I'm just going to take the first object out to my output. Once I'm ready to go, change this to write mode, and then I'm going to press play. But before I do that, I'm going to pause the video, and I will see you when I've got a cache. So we're back, and we have a cache. Now, something I found out that you will need to know is that if you just make a cache and plug that straight into your output, you're not going to get anything. It needs to run through the material. Needs to run through the material before you can see anything. But as you can see now, I can scrub the timeline. It's very, very fast. It's got all of my steamy smoke that I wanted. And of course, I've got all of the properties that I selected to go onto it. So that's pretty much basic smoke. Now, once again, we have two parts here. I've disconnected this from the file cache. Even if I plug it in, the file cache should pick this up and just read it. So it's not going to be calculating anything behind the file cache, which is awesome. That's only one half of the fire and smoke thing. Now we're going to go on to making things fiery or hot or something. Yeah, before we go on to fire, let's quickly talk about what smoke is. Now, most other packages, most other simulation systems will try and abstract the smoke. They'll turn it into a fluid, whatever it is. It is a fluid. It's behaving like a fluid. It has fluid attributes in the air and things like that. And this is something I'm putting in between smoke and fire because it's really important when we get to fire. Aero, which is this system, which is the fluid simulation system in Bifrost, doesn't so much abstract. It pretty much says, I want to work by real world principles. And so all of this stuff in the solver here, temperatures, things like that. For example, buoyancy, all of that kind of enable buoyancy, turn it on and off, that kind of thing, kinematic viscosity, velocity smoothness, all of that kind of stuff, accuracy, etc. That's all based on real world things. So the way smoke works is that smoke's a particulate. It's very, very, very fine particles of things like dust and soot, or water vapor if it's steam, and other things as well. And so what the simulation engine is modeling here isn't so much something that looks like smoke, it's more something that behaves like smoke. And this will become far more apparent as we get into the fire stuff, which is coming up very shortly, where in another package you might put together a simulation that does all this kind of thing for you, whereas in Bifrost and Aero, you're trying to just set up the real world. So what I like to say is that you're not setting up a simulation that looks like fire, you are literally setting something on fire. Or in this case, you have hot vapor that is rising and obeying all of its buoyancy laws, all of the physical properties that go in to make it. Cool. All right, enough about that. Let's set some stuff on fire. So we'll take this guy and we're going to need the burner, so we'll leave the burner out. All I'm going to do is hide the Bifrost graph and close it down, and we'll make a new one.